Now today we are going to talk about function. What's the meaning of function in mathematics? First, I would like to request you to view a short video about a mincing machine or a mincer. And after viewing the video, you may understand what is a mincer. Now you have seen the detail of the mincer already. Now this is a diagram for the mincer. Mincer actually is a mincing machine. It will turn the beef into the minced beef. If you put the beef here, it will come out to be minced beef. Okay. When you put a vegetable in, the minced vegetable will come out. And also, if you put the pork in, the minced pork will come out, right? And then we say, this mincer is a function. This mincer is a function. So in this case, we say the mincer is a function. It will turn the pork into the minced pork, the vegetable into the minced vegetable, and the beef into the minced beef. So if I put the fish inside, the minced fish will come out, right? This is a function. Or I represent in another diagram like this. This is the input, and here is the output. Okay? Now, when you put a vegetable here, it will come out to be minced vegetable. Okay? When you put the beef as the input, you will have the minced beef. And if you put the pork into it, the product will be minced pork. Okay, I put a dot here, dot here, dot here. So the machine here will bring this thing to here, and we will turn the beef into minced beef. It will turn the pork into minced pork. We say this is a function. We should put the function here, f. Now the lines and the arrows and the f here represent the whole machine. And how about these things? You can put the pork, you can put the beef, you can put the vegetable it can change. So we say this is the variable. Here is the variable. That means changeable. When you change these things, of course, the output will be changed. It is also variable. And this is the independent variable. And here is the dependent variable. Because when you put the beef, that means the beef will come out. It depends on the beef, right? That means that vegetable depends on the vegetable, so on and so forth. So this is an independent variable, the dependent variable. And here's the machine. Can you say that when you put the vegetable inside, it will come out as minced vegetable and minced beef? Can it be? No. When you put vegetable inside, only the minced vegetable will come out. Only one product will come out. And if I put, say, I put the apple inside, I put the apple into it, what will happen? I put the apple into it. Will there's nothing coming out? No. All the apple will come into the machine and then discard away as the minced apple. So for every input, there must be some output. Okay? For every input, there must be an output, and there's only one output. It cannot be when you put apple in, you have the minced apple and also the minced pork coming out. It's impossible. We say this is a function. Or I give you another example. We come back to this again. Now, I can say that the following is not a function. 1, 3, 5, and 10. And here, the 1 becomes 7, say. The 3 becomes 5, and the 5 become 21. And the 10 will give 100. At the same time, it gives 5. If in this way, the relationship between the independent variable and the dependent variable, the relationship between these two variables is not a function. The reason is, for the input 10, there are 2 outputs. So it's not a function. And how about this one? How about this one? A 10 here, 11 here, 17 here, and here is 12 minus 5, 7, 1,000. Now, the 10 come out to be 12, and when you input the 11, the product is 7. When you put the 17, there's nothing on the right-hand side corresponding to it. So this time, it's not a function, because for the input 17, there's no another value corresponding to it. So it's not a function. Now, let's repeat. What is a function? For a function is the relationship between the independent variable and the dependent variable. For every independent variable value, there must be one dependent variable corresponding to it, and there's only one value corresponding to it. It is function. Okay? And then we may say that, now return to another example, it is a function. Say, say 1, 5, 10, and 30. Here's 7, 5, and minus 2. Now, the lines and the arrows here means the machine. Is it a function, independent variable, and a dependent variable? For every input, there's output, right? And for every input, there's only one output. Well, you may see that 5 may be the output of the input 5 and the input 10. Well, that's okay. That's okay. It is a function. So we write f here. We may say that f is a function. It connects the independent variable with the dependent variable. We say this is the mathematical function.